Dear students at Salama College for Science and Technology, welcome in Lecture 7 of Expert Systems, which is titled Knowledge-Based Expert Systems. Lecture objectives: what is knowledge-based expert systems? Structure of knowledge-based expert system, features of knowledge-based expert systems, types of inference, development of knowledge-based expert systems, and lastly, advantages and disadvantages of knowledge-based expert systems. Knowledge-based expert system, KBES, is the first realization of research in the field of AI in the form of software technology. That means KBES represents the first innovation in the field of AI, especially in the 1970s, because at that time there are many software, but KBES represent the prominent brand at that time because the emergence of medical diagnostics systems and engineering systems acquired these types of the system the effectiveness. The structure of knowledge-based expert system, we can explain this by more details if we return to here to the paint. We can find that there are some components existing in the previous expert system like shell or expert system as general, user and user interface, inference engine, and knowledge base. The new component here is knowledge engineering tool. This represents a narrow knowledge base, engineered or organized by expert engineering. The user interface represents an intermediate tool between the human and the computer, between the user and the inference engine. When the user enter the question or the variables or ask the computer the question, the inference engine will receive the question, and then according to the property of the search engine, it search in the knowledge base to find the optimal answer. When it match the correct or the optimal solution, it return the result to the user again. Here is the knowledge engineering tool, which represent the new things in this structure, which is it represent the most important thing because the knowledge here is organized by engineering experts. We can return to our lecture. Features of knowledge-based expert system: problem solving, process knowledge expressed in the form of rules, and use symbolic reasoning to solve problems in a narrow domain. After we determine the problem, we can make symbols for the variable, for the database to be easy or to can be solved or can represent the problem in symbolic form like X and Y. Trace the rule pair. Trace the rules pair during a problem solving session and explain how a particular conclusion was reached. After we organize the knowledge and make the rules and make symbols for all the rules and facts, we apply these rules with a specified language, computer programming logic language like Prolog, and then get the solution. When we get a particular solution or conclusion, we evaluate this solution before we reach to another node. Quality of problem solving. Enhance the quality of problem solving by adding new rules or adjusting old ones in the knowledge base. As we said before, knowledge base include all the facts and rules related to the specified application or system. Here we can add new rules by the system, and we can review the old existing rules or facts in the knowledge base. Flexibility or flexible knowledge base. When new knowledge is acquired, changes are easy to accomplish. As we said in the first point, we add new rules to the knowledge base. When we add or discard facts or rules to the knowledge base will not be affected by negative. High performance, using algorithms and knowledge bases to find optimized solutions with great performance. The important two things that give us high performance is the algorithms and knowledge bases. That is mean our work or our system is apply scientific ways like algorithms or quality algorithm and knowledge base to give us optimized solutions. Types of inference. We have three types of inference: forward chaining, backward chaining, and hybrid chaining. We can explain this by more details. Return to the paint. Here is the paint. Three basic techniques are identified when inferring facts or conclusion from the knowledge base: forward chaining, backward chaining, and hybrid chaining. In this image, we see the lamp and the expert person, and this lamp refers that to new ideas or new innovation or mental production of the expert human, which we called inference. Inference means to produce a new ideas or a new innovative ideas related to the facts or to the rules. These types, the first type of chaining, that is mean we have many facts and notes. For example, this is the first note, and second, and third, and fourth, and fifth. And in the forward chaining, we start from simple facts and forward to the next node. In each node, we calculate the solution, the cost of solution according to the cost of the past and the previous node, and here get a solution. We will keep this solution and transmit to the next node, and again forward to the next until we reach the goal. And then we compare all these solutions and select the optimal solution from them. The backward chaining is an opposite operation of forward chaining. Start from the goal and backward until reach the first node. During this journey, we keep the solutions and then select the optimal solutions from them. The third type, hybrid chaining, this a mix operations between the computer or between the system and the expert. The expert intervene, or we need the person, or we need the human invention for some operations. For example, how to distinguish between the results, which is need a good selection or a correct selection for many solutions, and maybe the expert system may not select the correct solution. Here we need a human intervention or a human interference. At this time, the person or the expert person select one of the results, and the computer do other operations like repetitive operations, which is need a fast or high computer performance. This is the third type of chaining. We can return to our PowerPoint or return to the lecture. Types of inference, as we said, for word chaining is a form of reasoning for an AI expert system that starts with a simple facts and apply inference rules to extract more data and the goal until the goal is reached. Also, for word chaining, a technique used to shape an AI expert system that starts with the end goal and works background through, as we said, through the AI's rules to find facts that support the goal. For the third type, hybrid chaining, technique used by a human expert and at the same time expert system must employ complex inference that almost always include both forward and backward chaining with potentially many variations. Development of KBES. Development means to construct a new knowledge-based expert system or to develop an existing one. The first stage in this development is conceptualization. Conceptualization means the concepts needed to represent knowledge and the overall structure of knowledge control strategies must be determined before a preliminary system design can be completed. Like system development cycle, which start by planning and then analysis and then design and then implementation and then testing. Here we want to construct a software or knowledge-based expert system, which at the end is the software. We must define the main concepts of this system. For example, if we want to construct expert system for cancer illness, we must to define the concept of cancer, the type of cancer, the aim or the goals of this project or this system, the limitations of this system, the difficulties of this system, the challenges of this system. All this can be concepts and must be defined before we start designing of the system. The second stage is formalization. This stage involves design of the formal organization of the knowledge consistent with the language or languages used. The detailed design of the system is formulated by the experts and the knowledge engineer. Here we must to make formalization for the knowledge like the rules and the facts and the strategies and the language used in this system. This detail can be done by experts or by engineers. We said in previous lectures that the main people or the main human work in expert systems are experts, engineers, programmers, and users. But in this stage, we depend on experts and engineers. The third stage is implementation. In this stage, the knowledge engineer turns the formalized knowledge into working computer program. We transmit or we arrive it to the coding stage. Here we must construct formalized knowledge in a computer program like Prolog or Python or any other logic programming language. The last stage, which is stage 4, is the testing. The performance and behavior of the prototype expert system are iteratively evaluated through comparison with the human expert capabilities. This word is capabilities. That is mean prototype is a simple or is a small software or knowledge-based software. This software can be iteratively evaluated. That is mean evaluated many times, and in each evaluation we must correct the system from errors and rebuild the system again, or rebuild some of the components of the system and then make a comparison with the system goals or with the expert's capabilities. And we ask ourselves, is the expert system achieve its goals or not? It is the output typical to the human expertise capabilities or not? And then make evaluation and make correction and redesign the system again. Advantages of knowledge-based expert system: aid in expert decision making, especially when a human expert is not available. When the human expert is not available, it is better to use base expert system because it is capabilities in decision making. Provide efficient documentation for quick user access. Create knowledge by referring to and reviewing existing stored data. As we said before in the previous slides, when we create or construct the knowledge base, we let the system to add new facts or rules to the knowledge, or reviewing the existing facts in the existing knowledge base. Group data by analyzing and classifying different data. That is mean put the similar data in one group and then make analyzing and make classifying for these groups. That is mean each similar groups can be classified or can be put together. Improve decision making processes so users can work at higher levels of expertise. Here is disadvantages. This word is disadvantages of knowledge-based expert systems. Difficult to maintain, as some systems might require continual updating and organizational policies. That is mean when the organization change its policies, that is mean we must update the system according to the organization needs. Require large amount of accurate data, require training for new users to understand the system. For example, if the users are physicians or engineers, they will not have a lot knowledge of expert systems. they demand to make a training for them. Thank you very much. Meet you in the next lecture.